Welcome back. We are ready to start with our panel discussion. And we're very happy to have all our speakers and moderator with us right now. I request all them to mute themselves so that we can start the show with the panel discussion. And as soon as I count them, they can unmute themselves. Now, India is undergoing a green energy revolution, exceeding targets and quickly making affordable clean energy a reality. India has pledged to increase the share of our generation capacity that doesn't use fossil fuel to 40% by 2030. Today, generation capacity from renewable, hydroelectric, and nuclear sources has already reached 38%, putting India on track to comfortably exceed its target. Now, coal-fired plants currently account for over half of India's power generating capacity. So as India reduces its carbon emissions, will coal gasification also contributes to India's sustainable clean energy generation? To discuss this, we have an eminent panel of experts joining us now. We have Mr. Peeyush Kumar, Director Technical, Ministry of Coal, who will be moderating this discussion. We have Dr. R.R. Sund, Senior Scientist, Executive Vice President, Research and Innovation with Thermax, India. And we'll be joined by Mr. Sharma, Managing Director of Jindal Steel and Bar. We have Mr. Thomas Mathew, President RTG, Reliance Industries. Mr. Esvin Yadav of Talcher Fertiliser with us very shortly. We have Mr. Bob Carter, Group Vice President, Air Products. We'll be joined by Dr. Arden Mathew, AGM R&D Engineers India Limited. And Mr. T.S. Venkataraman, CMD of Esvin Advanced Technologies Limited. We also have Mr. Yanghao of Wuhuan Engineering with us. So before we start this panel discussion, I would like to come to Mr. Peeyush Kumar, who will be moderating this discussion. He's Director Technical, Ministry of Coal. At the outset, I would request him to please share his views on the place of coal gasification that it will have in India's carbon footprint and how to reduce it. I would request you, Mr. Kumar, to please start.
Good morning, everyone. This is Peeyush Kumar from Ministry of Coal. At the outset, I would like to thank the organizers for inviting me for such a great show, the conference represented by so many persons, and then especially this session, which is being represented by investors, licensors, engineering consultants, and then researchers also. I can see so many faces, Mr. Sonde, Mr. Thomas, Mr. Cartel. We have met so many times in various meetings. This is a nice approach at a time when government is thinking about an approach for 100 million ton gasification by 2030. There is a need to discuss what should be the way ahead, how to take this mission so that we can achieve our ambition, at least especially for the Atmanirbhar Bharat and then Make in India concept. You all may be aware that we have about 280 billion ton of non-coking coal. And out of that 280 billion of non-coking coal, we have a very small quantity of coal which is having ash less than 25%. So to meet the ambition of government, we need to think about the technology where high ash coal can also be gasified. We had thought about a strategy to take up certain projects which is based on low ash coal. We have already taken up certain projects in which coal is mixed with the pet coke and then fed to the gasifier. Mr. Sonde is there. He is already working on high ash coal gasification. So this session will be quite interesting, and I hope that after the session we can conclude with some of the 2-3 suggestions which then it come to the government for taking a decision for adopting those suggestions. So to set the ball rolling, I will request all the speakers, because we have 90 minutes and about 9 speakers. So if you give 8 to 9 minutes, I will be giving to each speaker. They should complete it, and then in the last, again, we will be giving 1 minute to each after everybody's speech, so that you can recommend at least 2-3 main points of your speech so that we can conclude. So starting with, let's have the researcher first, Mr. Sonde, who is working a lot on high ash gasification. I have heard him a lot. Ms. Anisa, I will be out for certain time in a meeting. So I think you will be now coordinating with the speakers one by one as per the list. And then I will be listening and I will be joining. Okay, thank you.
For sure. Dr. Sonde, would request you to kindly go ahead and make your address.
Thank you. Good morning, everybody. I hope my audio is okay, Anisha. Is it all right? I'm Sonde, not Son. I hope the audio is all right. Is it audible to everybody?
Yes, Dr. Sonde, it's absolutely
okay.
fine.
Good morning. I'll not take more than 9 minutes. Actually, I'm often reminded of this particular statement. Power is come. I think this particular very well in case of coal gasification, because I know a lot of people is, we have been talking about in 70s. We looked at it, what has happened in India, those Talcher, my doyen, my guru, Dr. Thomas is here. So we have a lot of story, not so good stories about gasification in 70s and what happened at Talcher, and we were a part of it. I was then a part of the atomic energy, and we know the problem that this country faced with a copper torch kind of an entrant bed gasifier. Then we know recently what happened in Angul on the JSPL and everything. And now I'm saying, no, the time of gasification has come. This idea has come now. And as I said, that nothing can stop this idea of gasification whose time has come. Why am I saying this? I would say this because on the strength of these three clear drivers, three clear things have happened over the last 3 or 4 years. Number one, I think it is now clearly established that the fluidized bed gasification is the best route for India's high ash coal. I think there are a few speakers who are there in this particular conference who will vouch what I'm saying, because enormous work which has happened for the last 5 years on the bubbling bed, fluid bed gasifier in a circulation mode has clearly proven, and we have done that Thermax along with IIT Delhi, Simfer, BHEL, EIL. I think EIL Mathew of my good friend Mathew is also here in this particular panel, will vouch that now on an oxy-blown condition, India's highest coal at around 875 degrees centigrade can be very well under a stable, continued manner. We can gasify. It's a big news. I know in 80s we worked. I was working with BHEL in looking at all that moving bed, the fluid bed, bubbling bed, and the fast fluid bed. Now today it has been very clearly established, and we are running this gasifier continuously in the Pune. And I'm sure Simper is working on this. In Delhi, we have pilots very clearly established that in fact we don't need a high temperature entrant problem that you can face. Design a bubbling bed is a very right concept for India's highest gasification. We have done it at a megawatt scale. Now, to go from a megawatt scale to a multi-megawatt scale, I know that today there are enough modeling, simulation, CFD, the direct particle modeling. So we have used some 4 different modeling processes along with IIT Delhi under the guidance of Niti Aayog. You must have heard Dr. Saraswat about it. There's a 60 crore program which is supported by Government of India, Department of Science and Technology. So it is very clear that we are very confident that from a current development in the pilot scale, we can scale it up to 300 megawatt. So that is one important, clear kind of a picture which has emerged, which is making coal gasification a real possibility for India's highest coal. Number 2, of course, the greatest thing that has happened is Government of India, our Honorable Prime Minister declaring 100 million tons of coal gasification. and we can use this particular technology for gasification, which would mean at least 25 million tons of crude can be replaced by using 100 million tons, because there's a 1:4 ratio for India's highest coal at about 3,500 kilocalories. At a certain carbon and hydrogen percentage, we can get almost 25 million tons of crude oil. So that is a great news, because now coal is available to at 1 rupee 50 paisa, same as what is available at TPS. So in terms of commercial value, you will be able to get the fuel locked in at about 8 to 9 rupees a kg. So that's another great news that has happened, which is making coal gasification an eminent possibility. And number three, the fact that we are able to now capture CO2, whatever residual CO2, there's a big research program which is happening of using a new catalyst, ruthenium catalyst, so that CO2 with a renewable hydrogen coming from solar PV or a wind power can be converted into methanol. And I'm sure Dr. Saraswat must have mentioned about it, make this entire gasification very high. There are emissions. So what I would like to say and conclude my talk is that technology is available for India's highest coal. We can do the scaling up. Coal is now made available to India so that India need not depend on imported crude oil. We have got the right cost of the technology so that the technology cost can be brought down under 2 crores per million tons per ton per day, which would mean that the cost of the methanol or natural gas or dimethyl ether or olefins that we are going to be doing can be made at the international market prices. We know how to capture the carbon dioxide, and all the components which go in our fluid bed technology, gas cleanup system, which are developed, which is based on an amine process, and a CO2 capture system will make this commercially viable, and a large amount of medium and small scale manufacturers can work in a tier 1 and tier 2 basis to make this technology Atmanirbhar and absolutely right technology for India, and our going to a green technology as a clean, zero emission, solar or a renewable and fossil hybrid, in my view, is the best pathway this country can look for. Thank you very much.
Thank you, Dr. Sonde, for your address. Definitely, the time is now for India to seize the opportunity and use coal gasification to its best, given that the reserves will only become older. And now is the time to use the coal with the technology available, with the scale coming through. There's a lot to look forward to. I would now request Mr. Thomas Mathew, President RG Reliance Industries, to please address the audience. Sir, I request you to please unmute yourself and start the session.
Respected dignitaries on the dais, of course, we are in different places now. The topic is, can gasification contribute to India's sustainable clean energy generation? So I see it a few points. One is clean energy, sustainable, and as far as gasification is concerned, can it be a contributor only, or it is going to be a bedrock for India's development? Gasification, of course, it does not mention coal gasification or petcoke gasification or biomass gasification. It could be any of these gasification. I have been in the industry for 52 years, and Sonde was referring to the historical development of gasification, alluding to that. Most of the time when I talk, I refer to the history. And 75 years ago, India had Asia's largest fertilizer plant in Sindri, which was coal-based. It took another 35 years to bring Talcher and Ramagundam. And it's another 25 years when Jindal came with the gasification. So we have sporadic inroads into gasification, different types of technologies. Why we could not sustain gasification in India? I think it is a matter for introspection. How come China is developing all types of technologies internally? Probably we can learn something from the Chinese model. That we should do. I'm happy to see that for the last few years, there is a lot of work being done under Sonde in Thermax and EIL and the Dhanbad School of Mines. But they're all focused on one particular type of gasifier. We should have a research and development where the technologists and the institute, academic institution all come together and work on certain projects and develop it. And it requires funding. It requires several types of pilot plants. Then only it can be focused. I have seen how China develops. China has got all types of gasification in their country. They are licensed it. And then they went into a sort of collaborative work with academics and technologies, R&D setup, and government funded them, liberally funded them. That is one way, a continued, sustained effort for development of the technologies, all types of technologies in gas. I mean, the coal conversion. That is my first point of it. Second is clean energy. Very clean energy is there, not so clean energy, and bad energy conversion. Then that we can see the bad boys are from the pulverized coal combustion thermal power plants. But they are also trying to become clean. Electrostatic precipitators, fluidized degasification, and NOx removal, all these things are planned for Indian power plants, and so they also become clean. Now, coal gasification is clean, but for the CO2 emission which is coming. So we should not have coal gasification where the entire CO2 is vented to atmosphere. We should have a mix of power, hydrogen generation, and chemicals protection from coal gasification. That's we have done in Jamnagar. The Jamnagar 10 gasifiers, the whole thing is around 10 million, equivalent to 10 million tons of coal. And when you say 100 million, you need at least 10 Jamnagar plants to be repeated in India. Then you will have 100 million. And that's not difficult. In the next 10 years or 15 years, it can be achieved if we start right now. Then clean energy, we have solar, we have wind energy, and then we have biomass gasification. That's also go with the coal gasification type. But the clean energy, when you say they are not continuously generating, so they should have backup power if they have to be continuously generating. And in that case, they require some new technology already developed and in practice of a battery backup. That means when power is not there, the battery can provide support. So then that will be become a very clean energy, especially where we are supported by diesel. All communication towers, our 5-star hotels, big hospitals, big malls, wherever we can see, big townships, all these can be supported by a sort of battery. So they can be supplied through a solar power plant, and then there has to be a separate maybe distribution network for this renewable energy. So there is a lot of things to be done if you have to achieve this. So gasification is contributing. Yes, it will definitely contribute in terms of power generation, but CO2 will be going out. And in terms of hydrogen generation, because there is a great emphasis on hydrogen economy coming all over the world, and we are also starting. So India is also starting in that line. So then this coal gasification could be a source for hydrogen. Chemicals. So in this mix, the chemicals could take away some of the carbon dioxide which is being vented out. So we should plan coal gasification as a source of power, a source of hydrogen, as a source of chemicals when you plan. So I would like to say something what we are doing in Reliance. Reliance also going in this. We have the gasification project already commissioned, 10 gasifiers. All of them have started up, and there are certain initial problems. We are sorting it out. And as I speak, already 7 gasifiers are already online for the last 1 month. So it will be possible. Another 1 year, we will be mostly running 9 gasifiers. So we produce fuel, hydrogen, and SNG, synthesis natural gas. We are also trying to develop chemicals, gas to chemicals, downstream of the gasification. And towards the renewables, we are very seriously considering to support the renewable projects which are coming with a battery, that is vanadium redox flow battery. Petco gasification produces a slag containing very high level of vanadium. It can be 6 to 10%. And that is, we will be one of the largest producers of vanadium. And vanadium-based flow batteries can support megawatt type of power plant, 100 megawatt, 500 megawatt. Even such a solar power plant can be supported by the vanadium flow batteries. So we are trying to get into that. And hydrogen economy, we are looking at production of hydrogen through solar. That is one way. And also we are working together with the Sonde's group to develop fuel cell. So hydrogen powered fuel cell which can drive even heavy vehicles. So that is one of our plans to go ahead. So gasification is not only a mere contributor, it will become the major stay, the bedrock of Indian industrial scene in terms of not only power, chemicals, and the new economy which is going to drive CO2 reduction. Power through hydrogen is also one way. Transport power, fuel which is being consumed and CO2 going. If we start using hydrogen, there will not be any CO2. So that is also one of the directions we should take. So thank you for giving me the opportunity to speak. Thank you all.
Thank you, Mr. Thomas, for sharing with us your vision of what we can do with coal gasification. It seems like the possibilities are endless and a lot of good work on the technology is being done. Thank you so much for sharing with us your ideas and the work that Reliance is doing when it comes to gasification. Now, I am seeing that some of the participants are, giving their comments. If you have any questions to specific speakers during this discussion, raise your hand. You'll get a chance to ask your questions once we have heard all our speakers. So do keep, putting in your questions. Also raise your hands with the name of the speaker to whom you want to direct your question to. We also have with us Mr. Venkataraman, CMD of Esvin Advanced Technologies. I'd request him to speak next. Mr. Venkataraman, Mr. Mathew has spoken about the different possibilities that exist and the work that is being done by companies already. Could you talk to us about what Esvin Advanced is doing?
Good morning to everybody and my friends, Dr. Sonde, Mr. Thomas, Mathew. Thanks for the Mission Energy to give me the opportunity to talk to people. I've been working on gasification for the last 20 years, and we brought the first demonstration plant for gasification of liquid biomass at the Sersai paper for biomass from black liquor. From there on, we left it to the American partner to do the biomass gasification. And then we are looking at more lignite gasification, my friend. Everybody is talking about coal gasification. We in Tamil Nadu, we are having large reserves of lignite. And currently, we are working on 2 projects as consultants to Neyveli on lignite to methanol. They are looking at producing about 1 million tons of methanol from lignite. That we are talking about 4 to 5 million tons of lignite per year. So that's fairly big size plant, and similar plants are right now being set up in Indonesia. Our friends in Air Products will talk about it. Somebody talked about it this morning. Connection I didn't have, but I know about that. They are doing 1 million tons per year ethanol, and that is from coal, I think, not mistaken, lower rank coal. We'll be producing from lignite, and ash is not a problem for us, Dr. Sonde, so we have low ash, and even wet lignite is the only problem I have. And that wet lignite at 50-55% moisture is a big challenge. And what we did was went and scout out for the good globally proven drying technology. Today, we are proud to share with all of you, we have tied up with the very well commercialized drying technology, which is rotary steam dryer, by which you can dry the moisture from 50% to 10% moisture. The caloric value almost doubles. It can go as high as from 2750 to something like 4800 GCV, kilocalories per kg. And that's something very close to bituminous coals. And low ash. Ash, something like 2 to 3% can go up to maximum double, say 8%. So I am with Dr. Sonde on the bubbling fluid bed. Bubbling fluid bed is easily the best to manage and control, and the low temperature, low fusion, AFT if you have. We can use bubbling bed and you get a dry discharge of ash. I think that's something that we have something in common to say. And this is something for lignite, we can use our two-stage gasification, which is the Americans are doing now, and they're right now setting up a plant for producing aviation sustained fuel from RDF. The plant is being set up in Nevada. It's 500 tons per day dry RDF, and as all of you know, whether it's RDF or lignite or coal, the feed characteristics only thing determined, but the gasifier doesn't see the difference. We have to only adjust that, and we are going to produce about 10.5 million gallons of aviation fuel, and the plant is under commissioning almost. First quarter of January to be commissioned. Thereby, we can bring the technology also to India. So we'll join force with all those who wants to do 100 million tons of gasification. It's not a joke. As I told you, 1 million tons of methanol requires only about 4 to 5 million tons of lignite and much less coal. So this 4 to 5 million tons I'm talking about wet. So if we go to about 2 to 2.5 million tons on dry basis, it is very similar to coal. So we have methanol is one route with the M15. The country is looking at import substitution. And ethanol is one front. They have attacked and they're doing it. And that's something good with the 1G has picked up faster and 2G is coming online. But that's not enough. We have an ambitious target of program to get 20% ethanol in the petrol by 2030. Can you hear me? Is there an interruption? Sorry, can I continue?
Yes, sir. Please continue, sir.
I heard some noise. Okay. So, what I'm saying is, the way of metal is out of 50% of the methanol other this will definitely be required to look at various technologies to do the gasification, not only to methanol. We are also looking at future DME. I think DME, all of you know, is dimethyl ether. It's a direct substitution to LPG. So LPG, 50% of LPG is imported in this country. So it's a huge replacement of LPG we are talking about. And it is directly done from methanol or even directly from syngas. It's a one-step reaction also. So all these possibilities are there, not to talk of hydrogen, it can be pumped into the natural gas. So So these are the various avenues. So syngas holds a key. Once you have the syngas, the modulus varies depending on what you want to produce. You want to produce methanol, you have to go modulus of 2. All of you know aware of that. So hydrogen CO ratio, CO2 is also required. So all these are something that we can work through our way and then see how we can achieve these big targets set by our Prime Minister, 100 million tons of gasification in a very short time. That is something that we have to start in a very fast track, in a very big scale. We should talk of scale. We should talk of at least millions of tons of coal and ethanol. I'm glad Dankuni and other coal fields are coming up. They are still talking about 1 or 2 million tons only, and small methanol plants. I have been inducted in the Niti Aayog committee. I have been talking to Dr. Saraswat also. We should look at ethanol plants of 3,000 tons per day, which is about 1 million tons per year. That's something the size we should look at, especially when you have lignite, which is cost is more than coal. So even if you dry it, if max the coal, lignite is higher than coal at pit head. So it has to be definitely made viable only by having an economy of scale. So we are looking at 2 projects, one with the Naval Lignite Corporation, another with the TIDCO, Tamil Nadu Industrial Development Corporation, both of which I am acting as a consultant. This is something we would like to see in the next couple of years. At least it is set to breaking ceremony. Thank you. I'll continue after our discussions.
Thank you so much, Mr. Venkataraman, for speaking to us and talking to us about the 2 projects that your company is working with. Yes, once we have the scale, it will all become cost-effective and one that will be widely adopted. Now, we've heard our speakers say that China has done a lot of good work, and we should learn from the China example. So I would like to come to Mr. Yankao of Wuhuan Energy and request him to address the gathering and talk to us about the China experience, what has worked for China, and what of that can perhaps be replicated in India.
Hi, everyone. Could you hear me?
Yes, we can hear you, Mr. Manka. Please go ahead.
It's my first year to attend the Gasification in India forum. Today, I attend the forum to instead Mr. Jinlin, because Mr. Jinlin is in a very urgent business trip. So I will give the presentation and attend the panel discussion. And as per the panel discussion topic, can gasification contribute to India's sustainable clean and energy generation? Wuhuan has 3 more ideas about this. First, as per Chinese experience to develop coal gasification industry, you see, we also have a long way to go through it. About 40 years ago, we have studied the coal gasification introduction, and in the recent 30 to 20 years, you see the modern coal gasification technology play a very big part in China's energy supply system, and is really a multi-integrated player of energy supply in China. And second, you see, the 40 years ago in China, we also lack of the experience on coal gasification, and at that time we find that GE and AP coal gasification is emerged in Europe and America. So after a good study on the 2 dominant advanced technology, Chinese introduced the technology, and after 10 years operation experience, we have developed a big group of human resource with abundant experience on coal gasification. And after that, we also have more innovation on the coal gasification with AP and the partners to solve the local problems in China. And the third point is with the advanced coal gasification technology development, the equipment manufacturing and innovation is also blooms in China. I see in Chinese we propose make in China, and in India you also propose make in India. We think because the resources situation and the human market and the market and then make in India proposing is similar between India and China. We think Wuhuan as very abundant experience in coal gasification can go with many partners such as our older Talcher and our vendors and licensors to make some progress in India. And we think Talcher is a very good start point to lower the market and lower the coal property in India. And after that, we have to say that because the diverse difference between the coal property between India, such as the high ash FT, that maybe there is some new problems emerged, but we think we must cooperate with licensor, owner, and other vendors in India to solve them and make progress in India, especially the first project, Talcher. Okay, that's all. Thank you.
Thank you so much, Mr. Yang Kao, for addressing the panel and speaking about the China experience. Of course, coal gasification is one where is envisaged by the government where we shall become Atmanirbhar or absolutely self-reliant when it comes to the usage of coal, so that we may cut down on the imports of fossil fuels, be it coal or be it even the oil and gas imports. A lot of work is being done, and I would now like to come to Mr. Bob Carter, who is with Air Products. Now, Air Products is one of the leading companies in gasification technologies. Mr. Carter, a lot of work has been done by Air Products around the world. In India, what is the opportunity that you see, and what do you think is going to work well because of the high ash content and calorific value of Indian coal?
Thank you. First, I just want to say good morning to everyone out there, and thank the organizers for putting on this event, and again, particularly this important topic. As several of my distinguished panelists have mentioned, developing clean energy solutions is one of the biggest challenges that faces today, not just in India, but really around the world. And it's something that will face us for the next several decades as we move forward. Air Products is focused on developing, clean, sustainable solutions and technologies for a full range of technologies for a number of different solutions. My colleague, Dr. Sirhan, he mentioned one of those solutions being green hydrogen, and a project that we have in Saudi Arabia. We're investing $5 billion to invest in a truly, zero or near zero technology for producing hydrogen with no carbon footprint or near zero carbon footprint. I think we recognize that type of solution isn't necessarily going to be able to be adopted by all countries in the world and all applications in the world, and so we need a range of solutions for different needs, and we need a bridge really to get from where we are today to a solution like that over the next several decades. And we see gasification being one of those technologies that will help bridge that gap. Air Products is investing heavily in gasification. We've acquired the Shell and GE technologies. So the Shell technologies, dry feed solid technology, for coal, for high ash coal in particular, we have the dry feed technology. We have the GE slurry technology, which is more amenable to low ash coal and petcoke. We have residual technologies from both GE and Shell, as well as partial oxidation technology. So we have a wide family of technologies that we've acquired, and now we're further developing those to optimize depending upon the type of feedstock that we have. And in India in particular, the high ash coal, we do have solutions that can meet those needs. So when we look at some of the investments that we've made, and again, we're hoping to make in India as well. We've been able to invest, and I think it's been mentioned earlier, in Indonesia in a coal to methanol project, a world scale project that will use our dry feed technology with coal similar to what we find in most places in India. We're investing in several projects in China. We're acquiring a large facility in Saudi Arabia, and then we're developing projects all around the world. That hopefully we'll be able to announce additional projects over the upcoming years, including several projects that we're working on developing in India itself. When we look at from a sustainability standpoint, we think gasification is part of the solution. It's for that bridge to sustainable clean energy. When we look at the ability to monetize some of the low value feedstocks, coal, petcoke, refinery waste streams. As well as when we look at the other ways that those feedstocks would be monetized, mainly combustion, you're producing a lot lower levels of SOx and NOx. So again, it's much more environmentally friendly from that standpoint. And I think as several other people have mentioned, CO2 emissions really are the biggest challenge from a sustainability standpoint with gasification. However, if you look at most of the projects and the technologies that are out there, it's actually quite easy to capture CO2 off the acid gas plants that make up these gasification facilities. You can capture over 90% of the emissions, and you can compress those and sequester them in the ground or use them for another value-added purpose. Air Products actually has demonstration facilities actually on a commercial scale in the U.S., where we capture over 1 million tons a year and have been doing that since 2013. We compress that into a pipeline, and then we transport that a few hundred kilometers, and then have that injected into the ground where it remains. So again, we can provide a full sustainable solution for gasification. Again, kind of an end-to-end solution that we think again is a bridge over the next several decades till we get to a true net zero technology. And so, I guess, answering the question, do we think the gasification is a sustainable technology? I think because of the element of carbon capture, in addition to the SOx and NOx reduction, we view it as is certainly one of the solutions to bridge that gap.
Sure. Sounds very exciting, Mr. Carter. And we will, of course, discuss during this session at depth on some of the challenges that could come up and how we could have these technologies applied, and we have some scale so that it is gasification becomes more widespread. And of course, if you capture the CO2, then the carbon footprint also reduces. Now I am seeing a few comments coming in on the feed. And I would request the participants, if you have any questions about anything that our speakers have said about the usage of technology, about the current conditions in India, do raise your hands and ask your questions. Please mention the name of the speaker to whom you wish to ask your question to as well. We will continue with this discussion. And I would now like to invite Dr. Mathew of Engineers India to please address the gathering and speak to us about the technologies that Engineers India is pioneering when it comes to gasification, because the the target set by the government is very high, 100 million tons, and not just reaching there in 3 phases, but there are a lot of fingers that are pointed to those who use coal, saying that it's a dirty fuel. So gasification is a clean way of using coal. Can we get scale quickly? This technology has been around for a long time, and there have been many start and stops in India. What is Engineers India's view on the technology and whether it can be applied on scale in India?
Good morning to all of you. Today's advanced gasification technology incorporates significant improvements over those early versions, increased flexibility, vastly increased scale, and new applications are driving gasification technology to gain greater prominence than ever before. The wide deployment of gasification technology can be largely attributed to socio-economic, energy security, and environmental issues. In addition, there is more variations in gasification technology, with some developers focused on reducing cost through integrations, while others focus on smaller modular gasifiers. Greater deployment of gasification still faces challenges, but the recent upswing, especially in China, clearly demonstrate the advantages of this technology for utilizing domestic energy sources to produce commercial products. In EIL, especially, we are addressing that for high ash coal, although that technology available and experienced, and people have worked much on that with low ash coal, especially with the high ash coal, there is some tricky issues. We are in Engineers India, we are trying to address that, and also we are doing research from coal to liquid fuels. As others are discussing, and you may be knowing that syngas produced from coal gasification is a umbrella terms, and it can be routed to various products based on the economic and situation dependent. And initially, we started with that chain from coal, gasifying it to syngas, then cleaning the syngas. That is also one tricky part. That cleaning the syngas makes suitable to the downstream use. And also, we have included in our research that basket that clean syngas to liquid fuels. So these are the 3-4 components we are trying to address, especially that for high ash coal, what are the tricky points could be experienced and can be addressed. That way, we have set up our coal gasification plant at EIL R&D Center. This project we started jointly with that BPCL as well as with that Thermax, with our development partners. So now that we have seen that when we are gasifying that high ash coal, especially that hydrodynamics part, that is a very tricky issue. We are trying to address it so that availability of the gasifier will be much with confidence. That research we are doing. So ultimate target our that to make that gasifier much more available in case of treating high ash coal, Indian coal. That Indian coal, we know that majority is that laden with high ash. So that area we are trying to address, and we have got much success also, and we are proceeding with that. So in that basket and in our EIL R&D Center, we have set up one bigger size coal gasifier, which can between that lab scale to demonstrate in between that sizes will be there, so that at least in a realistic scenario that tricky issues can be addressed. Especially, I told that high ash coal, that hydrodynamics inside the gasifier, that is one very important aspect we are addressing, and we have got a lot of success also in that area. And coming to that what you can say, pollination part, people are addressing. It has a lot of much wider use, that syngas. So considering that future cleaner energy in India, coal-fueled pollination as a product should be demonstrated with gradual advancement towards large-scale development. Scale-up issue in our EIL R&D Center, we backed with our engineering, experienced engineering part, we are addressing that scale-up issue, especially for high ash coal. That issue we are addressing. so that coal will remain in driving force in India's future energy mix, and we can contribute and a larger extent. It is difficult to find suitable alternatives. Though the gasifications of coal or petroleum coke and subsequent chemical synthesis, the polygenations of electricity, liquid fuels, chemicals for products, heating, syngas, etc. can be achieved. In addition, synergetic integrations of coal with renewable energy can help to meet overall energy requirements that can alleviate liquid fuel shortages and reduce coal combustion emissions and other energy related issues simultaneously. From a technical perspective, polygeneration needs to be demonstrated, including the economic benefits and environmental capability, and thus carries a great strategic significance for India. So in EIL R&D Center, we are trying to integrate all that little issues of technical component altogether, and complete chain we are trying to scale up so that we can contribute in that vast energy needs or future requirements of India. Thank you very much for your attention.
Thank you, Dr. Mathew, for speaking to us about the technologies that Engineers India is developing, so that we can, bring scale to coal gasification in our country, because that is the one thing that everyone is watching for, because we have a huge target. And if we can do this in a clean fashion, it will really be, like we say in Hindi, Sone pe suhaga, lower carbon emissions, utilizing our own, reserves which are abundantly available. This is certainly be, the best thing for India. Mr. Kumar, Mr. Peeyush Kumar, if you're here, sir, I request you if you can join us now, and if you have any comments to make. Having heard all our speakers, would request you to please make your comments here. Okay, I think Mr. Kumar is not here for now, but we do have a few questions that have, and comments that have come in from our participants. So we have a few questions that have come in. Mr. Mathew, there is one question which has come in from Mr. Randhir Kumar of Indian Oil Corporation. So the question is, are RIL gasifiers currently running on 100% pet coke? What is the availability factor for one gasifier at RIL?
Our gasifiers are running between 70 to 90%. We have not gone to 100%. And now we are trying to run only 7 gasifiers out of 10 and established. So you can say 70% of the availability. Overall availability as on today could vary between 60 to 70%, not more than that. You have to go up. There are a lot of actions done, and we are in the process of doing that. So that's the answer. But if you allow me, I want to speak a little bit more regarding.
Yes, sir.
Go for open cast mining. The ash content was going higher and higher. It is very obvious, the overburden getting into the coal and making the ash content high. I see the near developing India now. If gasification has to go a big way, I think India has to reintroduce underground mining with advanced technologies, at least in a few coal mines. This is one of my suggestions. Then lignite. When I was looking for technologies for Talcher ammonium in 70s, I had gone to Turkey, where they had plenty of lignite, and they were using entrain flow gasification for making ammonia and urea. Gasification can be used. It will be very good for lignite. You are the technology. We are say make in India, make in India, not made in India. It means get technology, install it and operate it. That is.
Mr. Mathew, I'm afraid we're having a problem hearing you.
Outside or ask outsiders to put technology in India. It's not. Putting up a plant is not a big thing, but developing technology is real strength of the nation will be shown developing technologies. I wanted to say some of these things was coming to my mind. I was a strong believer in developing human resources. He mentioned he has developed human resources. Technology development has come out of developing human resources. It's not an easy task. Somebody is doing something is not national program, national policy has to be developed for developing human resources in coal industry. Not only gasification, coal is used in many other ways, so it can be developed. So there, even now, when we have problems, we go on literature survey and we found a lot of work has been done outside India, not in India. We get all that information from outside India. So why can't we develop technologies and have this sort of information in India for the technologies? Now we are operating more and more. Gasification means we need a tremendous amount of knowledge and the skills for the people to operate the plant. So there should be special attention to that. Thank you.
Right. Mr. Mathew underscoring the need to have human resource development in the coal sector as well, because not only do we need the plants, we also need to develop our own technology, and for that we need people to do the same. Mr. Mathew, we have a few and to the speakers. We have Mr. Roshan Singh. He's Deputy Manager Coal Preparation, Central Coalfields Limited, joining us from Ranchi, I think. Mr. Singh, I'd request you to please go ahead and ask your question. Please mention the speaker to whom you're asking the question to.
Thank you, Anisha ma'am. Am I audible?
Yes, we can hear you. Please go ahead.
Thank you. At the outset, I would express my gratitude and my reverence to all the 10 speakers. My first question is to Mathew sir, and I would like to know about the feed characteristics of coal that is being fed to the gasifiers of RIL.
RIL, that question I did not answer. We are blending coal with petcoke. Petcoke is very less reactive, so the conversion per pass is not very high. So we thought to reduce the quantity of petcoke and introduce a certain percentage of ash. Because the gasifier has been designed for low ash, petcoke has got only less than 0.5% ash. So petcoke is an ideal raw material, ideal feed for gasification because it is a very less ash. And with the fluxant, they come up to maximum 3% ash. So we can go up to 10% ash. So we are importing coal. We are not using Indian coal. We are importing coal having less than 20% ash and blending it to a maximum level of 10%. But if you get a low ash coal, we can still go up. But we are limited to now that. So availability of low ash coal also is not a problem, but we have to procure it and make a trial in the plant. So one by one, we are making various test runs to prove the reliability and availability of the gasifier. So gasification, any technology, even if it is practiced elsewhere, it requires a lot of learning. You will face maybe several problems, maybe related to the equipment. So the equipments may not be what the other plant is using. So the equipment problems may come up. So that is where I was telling about equipment development in India, manufacturing various types of equipments required for coal industry. That also has to be developed. Thank you.
Right. We also have with us Mr. Saurabh Palsania, Executive Director, Dalmia Bharat Cement, who's ready with this question. Mr. Palsania, please do tell us who are you addressing this question to, and please go ahead and ask the question.
Yeah. So I was just hearing Mr. T.S. Venkataraman, who's MD Esvin Advanced Technologies Limited, Chennai. And I could understand that they have technologies with them to gasify RDF and municipal waste. So that is where we just wanted to know more about it, as we are using co-processing a lot of RDF and municipal waste in our cement plants in Tamil Nadu and Andhra, as well as Karnataka and Odisha. So we are just looking forward for some solution for gasifying RDF, as it contains a high level of ash content, which is not good for cement product manufacturing. So we were just looking for an solution for that.
What is your specific question on that? Whether they can answer that.
Specific question is, we are looking for technologies to gasify RDF.
You want to gasify RDF and then produce what?
That gas can be used for using it as a fuel into the kilns, rotary kilns.
You want to use a syngas. Using syngas as a fuel is a sin. Because synthesis gas is normally made for synthesizing chemicals. So we can do the RDF for you, but that will be expensive syngas. So as I said, synthesis gas meant for synthesizing chemicals like methanol and other things. But to produce it directly as a fuel into your furnace, it may not be economically viable. You have to compare RDF price also. RDF price itself in India is high because it's not organized. The aggregation, the source segregation, all that is to be taken care of. What is your RDF composition? Where do you get it from? Is it mostly municipal solid waste?
So it's municipal solid waste also and a biomining waste also.
Who does RDF for you? Who does it sort it out and make your refuse derived fuel? And what is its caloric value?
So calorific value ranges from 2,500 to 3,500 kilocalorie per kg. And basically, it's called RDF, but it is a SCF. SCF, that is a...
Okay.
So municipal corporations, they are able to only segregate and make it a SCF. And similarly, the biomining dumps, which are being owned, auctioned, and they are being taken care of by companies like Sigma and others, they are only converting that into a SCF.
It's a low caloric value, so it can be directly done as a producer gas. But we'll be happy to talk in private and give you what we can offer for you. So we'll be willing to help you. Thank you.
Sure, sir, sure.
So Mr. Palsania can connect directly with Mr. Venkataraman to discuss the solutions that could be offered. We have next Mr. Prabhat Verma, CEO, Futuristic Technology Solutions Program, joining us now with his question. Mr. Verma, please go ahead, ask your question, and please mention the speaker to whom you're asking the question.
Hello?
Yes, Mr. Verma, go ahead, ask your question.
My question is, I remember a few years back, we did had some IGCC projects in India, and Jindal and Tata Power took a lead in that. And they did the technology transfer, technology tie-up with Sasol and one more company. Also, I believe BHEL did some tie-up and did some pilot project. But we were told that because of Indian coals having very high ash content, IGCC is not successful in India. So I just wanted to know, because again, we have started talking about gasification. There are other ways of gasification, I know. Those are all futuristic technology and a lot can be done. But my question is about the coal, is really this Indian coal is worth using for IGCC project, and is it really worth having the low cost power generation? This is my question from the expert here. Thank you so much.
Right, Mr. Verma. Dr. Mathew, would you like to answer this question, since you have spoken about the quality of coal and how that is not a constraint? So could you kindly try to answer this question, sir?
I can. Can you hear me? I hope.
Yes, sir, I can. Please go ahead, sir.
All right. See, using syngas in IGCC is not the problem. The problem is what type of feed you are using to produce the syngas. That's the issue. In Jamnagar, we are generating 1400 megawatt power through IGCC. We are our petcoke gasification produces syngas, and 50% of the syngas is fired in our gas turbines. So only gas turbine needs earlier it was liquid fired, natural gas fired. Then we have to make modification in all the gas turbines to make it run on syngas. So that's not an issue. IGCC means syngas produced and firing and getting steam and power, and even the steam can be used to drive steam turbines. So if it is only a power plant, we can make it that way. But coal is an issue. So either coal, we can design gasifier for high coal, 40% of coal. We can design. It has to be designed. Then only that can be used for gasification of Indian coal, because all the coal ash will be converted into slag. So the slag mostly tapped from the bottom of the gasifier. So that part has to be separately designed, ash handling facility and all, and we require some more energy to gasify. So that means the specific consumption of coal per 1000 meter cubed of gas will be more. That cost has to be worked out. If there can be some subsidies to coal can be made available, then that is also possible. That can also serve the purpose. These are all government policy and government interventions are required at every stage. If you leave everything to somebody to bring some outsiders and put the plant in the place, it may not work.
Right. Dr. Mathew, let's also bring in Dr. Mehti into this because he did speak about development of technologies as well. So, Dr. Mehti, what would you like to say to Mr. Verma's question about the plans that were made and how they can go ahead and what is it?
In present scenario, we are not looking that much on that cost benefit analysis. We want to extract syngas efficiently from that highest coal. First, that technology should be efficient. After that, this alternative routes and cost scenario can be looked into. Presently, we have not seen that way. First, technology should be smooth and available. That aspect we are looking. Later on, in competitive scenario, we have to see so many routes are there from syngas to utilization of syngas.
All right. So the focus first on the technology's efficiency. We have Mr. Peeyush Kumar with us as well. Mr. Kumar, if you've been listening to the conversation that we've been having with the experts here, we've heard the experience of the Chinese manufacturers in turning coal into gas. We heard Air Products also talk about the promise of hydrogen and how once the CO2 is captured, how the carbon footprint is reduced and how much more we can maximize what we get from coal. Would you like to make comments here, sir?
I will just continue what the earlier speaker has mentioned. Basically, any project will come into the existence once it is financially viable. So when you are asking about IGCC or see what happens that syngas, you have to utilize the syngas for various end-use products. You can utilize the syngas for the purpose of power generation, for the purpose of steel making. You can use it for the purpose of methanol, or you can use it for the purpose of production of APIs in the pharma industry. You can use it for ammonia also, ammonium nitrate, fertilizer. So a lot of products are there which you can produce. The problem is when you compare with pet coke and coal. Pet coke is a product which is coming out of this, and if it is not used somewhere else, so the cost of pet coke doesn't matter much because it is just a waste for the industry, and then they are utilizing it for that purpose of gasification. But when it comes to coal you cannot mine at a zero cost because there is a mining cost involved with the coal. Government has already given 20% rebate on revenue sharing if you are using coal for gasification purpose. So government has come up with certain reduction in your revenue, some tax benefits you can do for the gasification purpose. But the major thing is that you have to identify that which product is financially viable. Government is thinking about reducing further taxes. What Mr. Naveen Jindal has told, that coal has been heavily taxed. So government is thinking about in that direction, that how to reduce the tax burden on coal and make it available for the gasification purpose. What happens that under the import substitution, government is also thinking about mixing methanol with petroleum, gas means gasoline, petrol, 15% M15 fuel. So there is a trial run going on. So suppose that mixing of 15% of methanol is there, then there will be an opportunity for coal gasification to produce methanol. So right now our aim is to find out the product which is financially viable, and the projects become financially viable. Whatever the government support will be there, that will be given. And if it is import substitution, definitely government will give some support to the coal gasification part. So that's why I think we have now 15 minutes left. So
Right, Mr. Kumar, it's very heartening to know that the government will support those projects and those products that will help in import substitution. Mr. Parpar had raised a question on IGCC, and I think Mr. Bob Carter wants to add something on that. So if I can just go over to Mr. Carter so that he can explain how IGCC, the capital cost, will become viable in India.
Yeah, sure. I'd be happy to add to the comments from the other panelists. When you look at producing syngas from coal, you really have to look at, I think, is Mr. Kumar was pointing out, what's really the highest value path you can do with that syngas. And I would say in most cases that we've looked at, it's generally a higher value to take it to methanol or ammonia or some other chemical feedstock over power. In some cases, power does make sense, depending upon the other alternatives to make power in that geography and what the other options are. But I would say in general, most of the time that we look at IGCCs, it does appear that, the higher value path is generally methanol or ammonia versus power.
Right. So that's your value add on that subject, by how to, make the IGCCs most efficient. We also now have with us Mr. Shakti Pandey, former executive director of ONGC, who has raised his hand and wants to ask the question. Mr. Pandey, I would request you to keep your question brief and please tell us who you're asking the question from.
Yeah. This question goes to Mr. Thomas Mathew. And for that matter, any person who can think that can add value to my answer, the answer to my questions that can add to my value now. Now, in coal gasification, we are producing syngas mostly, and small amount of carbon dioxide, and very negligible to methane now. And the heating value to the syngas is being added primarily because of the presence of hydrogen. If you take out the hydrogen from syngas, the heating value of the syngas itself comes down. So what I wanted to know from you that you produce hydrogen from the coal gasification by drawing the hydrogen out of the syngas. Don't you think that the heating value will impact, and in turn it will impact the industries where it is being used as a heating media? Have anyone or any person can make a comment that how it is going to affect the overall utility of the energy if I draw the hydrogen from the syngas? Because you can get one thing at the cost of other. I think I'm clear to my question. Yeah. Please.
Your question is clear.
Yeah.
Syngas is a specific product which is very versatile. Very versatile means they can make hundreds of chemicals out of syngas. We are making a survey of what all chemicals we can make. You don't take out only as hydrogen. At least there should be an economic use of hydrogen. Say, for example, ammonia plant. ammonia plant, we convert the CO also to hydrogen by water shift reaction. Then CO2 comes. So hydrogen and nitrogen from the ASU plant, which produces oxygen, nitrogen will be there. So hydrogen and nitrogen produce ammonia, and ammonia and CO2 makes urea. So in that case, you have a ammonia urea complex. That is the best use of coal because there's no CO2 going out, and the hydrogen is also fully utilized. Now that is one use. Now heating, you are using it for say IGCC. We need not take out anything. I mean, that CO2 is also good to get more flow through the gas turbine. So when we are using syngas for gas turbine, we don't take out anything. CO, hydrogen, CO2, everything goes into the gas turbine. And it gives better efficiency for operation of the gas turbine. So we have to know what you are going to do with the syngas. Syngas, say for example, hydrogen, we take out from the gas using PSA, pressure swing absorption. We have seen after pressure swing absorption, the vent gases have got higher calorific value than syngas. So we are using it as a fuel somewhere else in the plant. So I mean, integrated complex has got tremendous utility for gasification. Another thing is SNG. We were taking natural gas as a fuel in the refinery when gas was $18 per million BTU. That is how we started the petcoke gasification, and it has gone down as low as $7 per million BTU. Now it is going up. So at that time we can produce SNG. We are producing SNG, synthetic natural gas, by methanation route. Hydrogen, CO, CO2 can be methanated to produce methane, and that is being used in our plant as fuel. So there is a lot of flexibility in using syngas. So Venkataraman was telling, you should know what you want to use it for. That has to be absolutely essential. More and more ideas will come. Now we have got a syngas with us. We are looking at so many other options which can make our complex more economic. Am I made it clear?
Yes, Mr. Mathew. Mr. Kumar, would you like to add something here to the question that was raised, or would you like to make any comments? I think Mr. Kumar is unable to hear. Mr. Venkataraman, please go ahead.
Yeah, I just had an observation that we looked at very closely on a pre-feasibility report for TITCO to produce IGCC power versus methanol, the valorization. IGCC, Thomas Mathew can do it because he's got a huge plant. Unless you go to 600, 800 megawatt, IGCC doesn't make sense. And the two, you had to have CCS, carbon capture. So all these are making IGCC a little bit more complex. And there are very few plants in the world running IGCC successfully, and they are all around 600, 700 megawatts. So to look at that size, then you must compare with the supercritical, critical coal combustion power projects. So this cost of per megawatt IGCC is very high. It can go as high as 15 crores a megawatt. So IPP, independent power producers in IGCC, I don't think it's a viable solution. It will work for Reliance because they have multiple applications for the syngas. So that's why it is able to sustain. That's my observation. Thank you.
Mr. Kumar, would you like to add something?
I just wanted to say that the coal gasification route, it is basically to utilize the chemical property rather than the heating power of this coal. See, CO plus H2, this we are producing. Basically, what has been told, the H2 we are producing, when it will combine with N, it will make NH3. When it will be combined with Fe2O3, it will take out O, and then iron will be produced. So basically, the hydrogen, the chemical property of hydrogen and CO, this is used to remove oxygen and for other purposes. So we should not concentrate much on the heating power. we should think about the chemical property and the products which we can generate from them.
Right. And now let me take in another speaker who has a question here. We have Mr. Anup Sharma. He is MD and CEO of BTG Engineering Solutions. And he has a question. Mr. Sharma, please go ahead, ask your question, and please also name the speaker from whom you're asking the question.
Yeah, thank you very much for this opportunity. Can you hear me?
Yeah. Yes, I can.
Yeah, thank you very much. My question is for Mr. Peeyush Kumar. Whenever we talk of new technologies, I think very right emphasis was given by Mr. Thomas Mathews that we have to develop our own technologies. But the problem is coal gasification being a very capital intensive project, and this is only big companies only can go for these projects. And whenever the big companies opt for a technology, they always ask that there should be a commercial installation of that particular technology. But unless and until the commercialization of these new technologies is promoted by the government, these cannot be materialized in the market. So is anything being planned that whenever a new technology is there, some pre-qualification criterion are relaxed for those new technologies?
Basically, whenever you have developed a technology, there is a phase, pilot phase, commercial scale. That is the way of developing a technology. See, once you are thinking about developing certain things, I suggest that suppose somebody has done some research work and something has been proved. If you want to prove the same thing, see, there are a lot of licenses. There are licenses available. Everything becomes the cost effective. Naturally, if you are developing a technology, you want to ensure that the cost is reduced. Otherwise, when the technology exists, if again you want to do some research, this must be for the financial purpose or for technical upgradation of certain things. So there is an approach. If you have developed certain technology at laboratory scale, pilot scale, commercial scale, unless otherwise you do the commercial scale, nobody is going to invest 5,000 rupees on those technologies. So government, nobody is going to take a chance, because some of the methanol plants which will be set up, especially in the coal sector, we are thinking about 4 to 5, 6,000 crores are going to be invested on that. So if you want to ask some company to take that much of business risk, you must be a commercially accepted technology. So the government will definitely, there are R&D routes for developing the technology, government is supporting, and if it is there, definitely it will support. But you cannot just say that don't go ahead with the already existing technology for such a huge investment. Anisha, I think we have 4 minutes left now. We need to conclude now this session. This was a good session. As a moderator, I would just ask all the speakers, if you want to make one comment in this session, what should be done for coal gasification way ahead. Bob Cartel, starting with you.
Thank you. Yeah, I didn't have anything specific to add. I mean, I think obviously the environment in India is changing. I think we're seeing that. I think we're excited about it. We're seeing, I think the government, supporting gasification, and again, a very pro-gasification agenda. We're starting to see the projects and the opportunities develop. So again, I think you're doing the right things. I think, again, and Air Products is very excited about those opportunities that we see.
Coming to Mr. Yankov.
Hello.
Yes, your last comment in this session as a way ahead.
About just now, I heard that there is some question discussion on IGCC. I think that I want to share that in China, the IGCC is implicated in Tianjin, but you see, in the first several years, it's not successful. And after that, because in China, the supercritical power generation, and the ultra high voltage power transition technology is grown very statics, and after that, the IGCC topic is not so hot in China. So I just share that. Maybe if we find something in difficulty, we could find another solution to solve it.
Thank you. Last chance, Mr. Thomas. You want to say something to conclude?
Yeah, I have mainly two proposals. One is regarding the field. I always advocate at least a reintroduction of underground coal mine, because we are not going down so much. Our reserves are below 300 meters, up to 600 meters. If you want to take advantage of that coal, we should start underground coal mining. And India had so much of underground, which are all stopped. China has got 90% underground mining. So even as a trial basis, we should allocate some coal mines for underground coal mining. That is one of my suggestions. Because all these ash
Mr. T.S. Venkataraman.
I also have a suggestion which I will end it at a later stage.
No, I have the second suggestion is a geological study has to be taken up in the subcontinent to find out which are the rock formation where you can sequester carbon dioxide. I don't know whether such a study.
Thank you. Thank you. Thank you. Mr. T.S. Venkataraman, just one line if you want to say, because 1 minute is left now. Your mic is off.
Am I audible now?
Yeah.
Yes.
Yeah, I just want to make a point here. Just like the ethanol blending program, where the government stepped in and supported the ethanol pricing, especially for 2G ethanol, I think we should have for M15 methanol also special pricing strategy, not to compare with imported methanol, which is hardly about 22 rupees a kg. So it has to be much higher than that in order to avoid import. So this is the one I have to make here for the benefit of all others. Thank you.
Thank you. Mr. Mathew?
Coal gasifications, that
Could you hear me?
we have to continue as it is a capital intensive technology. So government should at least support up to demonstrations of the technology to show our increase our capabilities and confidence on that.
Mr. Khatri, you wanted to say something?
Yes. To success of gasification, we would like to have a very strong support from Government of India. We would. I am open, and I am open to bring the deliberations, bring any experts, bring everybody together. But we would like to have listeners to us, listeners to the industry. As I correctly said, though the subject is very interesting to the entire country, right from the Honorable Prime Minister Shri Narendra Modi ji, the Minister Coal Shri Prahlad Joshi ji, Minister MOPNG Shri Dharmendra Pradhan ji, but I refrain to say that we've been in touch with their officers for last 6 months, and unfortunately, due to some several reasons, we have not seen them on this stage today. This is very painful to me, and maybe many reasons behind. But one reason can anytime stop to share about 5 minutes and being present. We would like, if we would like to have the success of gasification, then I right now again say that we need a very, very strong support from Government of India. Thank you.
Thank you. I am here on behalf of Government India. So I am telling you that government is committed to support this coal gasification process. But the industry must also think that government is not going to give coal to them and ask them to produce, and then they will take everything. The business has to be taken care by the private sector or public sector. Government can give support, but it cannot work on behalf of the industry. We are here to support you in each and every manner. We had advised the public sector to take ahead and take up some gasification plants. It has already been taken up. I will request everybody will have to reduce their profit margin, not only government. It is for the engineering consultant, it is for the researchers, it is for the industry, it is for the coal producer or the persons who are converting coal to gas or to various products. Everybody, for the success of this gasification, they have to reduce their profit margin, and I am sure that government is committed and this gasification projects will come up. We are committed to ensure that the high ash coal is also gasified. That's how we can achieve the 100 million ton gasification. I will request the organizers to whatever the recommendations are there, even some suggestions are there, you can pass on to us so that necessary decisions, actions can be taken. About the underground mining and the coal, I tell you that GSI and CMPDI are continuously exploring the coal reserves in the country, and whatever the coal profitable it can be taken out, it is being taken out. We have already auctioned so many underground coal mines also. It is open to the industry. They can take care of, they can bid, they can take out the coal from underground mine also.